Alright, so this video we're going to look at graphing cosecant function. Now, uh, in order to graph cosecant, you need to know how to graph the sine function. And in this video, I have three examples. I'm going to do one example is going to have its own video. One of them will be just a regular, straightforward, you know, graphing. Uh, Another one, it'll have a left or right shift in it, and then that'll be example 2. And example 3 will have a left or right shift, and it'll have a up or down shift in it. Okay, so check all three of them out. Alright, so first let's just look at graphing a sine function. So if we have y equals sine of x, okay, as long as you can graph this, you can graph a cosecant. So just real quick, we know the period is equal to 2 pi over b, and b is the number in front of x, so we can see in this case b is 1, and so our period is 2 pi. And if we graph this, and we're going to graph it over one period, we'll graph it from 0 to 2 pi, and we know that, and we need to break this up into 4 equal intervals. Okay, so we'll go halfway between 0 and 2 pi, which is pi. Then we'll go halfway between pi and 2 pi, and remember, to go halfway, it's just pi plus 2 pi is 3 pi, and then half it, so 3 pi over 2. And then halfway here, 0 plus pi is pi, divide that by 2, that's pi over 2. And the max and min, the amplitude's 1, so our max and min is 1 and negative 1. And I do have a video on the sine function, graphing it. Check that out. It goes into a lot more detail than what this does. Okay, this video's kind of assuming that you know how to graph a sine function. Alright, so what we know about the sine, once we break it up into these intervals here, we know the sine function starts out at 0, and then it goes to its maximum, and then it goes back to 0, and then it goes to its minimum, and then it goes back to 0. And so this would be our sine function. That would be the graph of the sine. But the main thing is getting these points here. Okay, you got to get these points here, and then you know that it goes 0 max, 0 min, 0. Okay, alright, so let's take a look at our example. Alright, so let's take a look at example 3, graphing cosecant function. So the main thing is, we got to graph the sine function, and we just kind of briefly went over that at the first part of the video. And if you need to look at how to graph sine function in more detail, I've got a video on that. You can check that out. Alright, so let's go ahead and get started. Alright, so we got y equals 1 minus 2 cosecant x plus pi over 2. Alright, so what we need is we need the period, the interval over which we're going to graph it on, and we need the amplitude. Well, we can see here that the amplitude is 2. That's the number in front of cosecant, or well, that would be the amplitude for sine is 2, because remember, the first thing we have to do is graph this one. And the reason we're graphing this one first is because we're going to use it as a guide to graph our cosecant. Alright, so now I know, to graph the sine function you need the period, and of course this would, you'd get the phase shift and all that. Okay, I'm going to show you a little bit. I think it's an easier way to do it, to get the period, the interval over which you're going to graph it. And so we've got x plus pi over 2. So whatever you're taking the sign of right here, just take that x plus pi over 2 and put it between 0 and 2 pi. All right. And then what we'll do here is solve for x. So I'm going to subtract pi over 2 to all three parts. And so that's going to give me negative pi over 2 less than or equal to x less than or equal to, and then that would be 3 pi over 2. All right, so this is what we're going to graph it over. Okay, and actually, if you're asked for the phase shift, see this one over here, the negative pi over 2, that's your phase shift. Okay, and to get the period, well, you can do the 2 pi over b like you normally do, or you can just do this minus this, and that'll give you the period. Okay, all right, so we know we're going to graph it from negative pi over 2 to 3 pi over 2, and I'm just going to put that over here and erase this so it'll give us a little more room. Now we need to draw our xy coordinate system. So now look, I've got the y-axis here, and then if I go to put negative pi over 2 and the 3 pi over 2 on the x-axis here, well, where do I put them? Okay, we don't really know. Is the negative pi over 2 real close here? Would it be more over here? Where do I put the 3 pi over 2? Well, not really sure, so let's erase that, and let's mark off the negative pi over 2 and the 3 pi over 2 on the number line. And what we have to do here is break this up into 4 intervals, 4 equal intervals. So I need the midpoint between these two, and then once I get this midpoint, I'll find the midpoint between this number and this one, and then I'll find the midpoint between here and here. And then once we get these numbers laid out, we'll have a good idea where the y-axis goes. All right, so let's go ahead and find the midpoint here, and all you do is you just add the two that you're looking to find the midpoint between. You add them up and then divide by 2. And so if I take negative pi over 2 plus 3 pi over 2, well, that equals 2 pi over 2, which is pi. Yeah, which is pi. And then if I take pi and half it, I get pi over 2. So this would be pi over 2. Alright, now let's get the midpoint between pi over 2 and 3 pi over 2. So same thing, just add them up. So I get pi over 2 plus 3 pi over 2, and that's 4 pi over 2, which is 2 pi. And then I half that, so 2 pi over 2 is pi. And so this would be pi. And then you can see here the midpoint here would be 0, because if you add the 2 you get 0, and then you half 0. I'll just go ahead and write it down and show you. So negative pi over 2 plus pi over 2 is 0, and then if I half the 0 I get 0. Alright, so there's 0, and look, that tells us exactly where the y-axis is, and now I can draw it in. Okay. Alright, now if you notice in this problem, we've got the the amplitude is 2, so I know my maximum and minimum value is 2 and negative 2. So let's go ahead and put 1, 2, 3. Let's put negative 1, negative 2, negative 3. So we'll just call that 1, 2, 3, negative 1, negative 2, negative 3. Now, You see the 1 here? Don't even worry about it. For right now, let's do this. Let's just erase the 1 and pretend like it's not even there. Okay? All right. So if you remember, for sine, we're starting at negative pi over 2. Remember, sine starts at 0, then it goes to its maximum, 0, then its minimum, and then back to 0. So here we're starting out at 0, and then it goes to its maximum, but since it's a negative in front, it's going to come down here to a minimum. Okay? And then it goes 0, maximum, 0, and then it goes to its minimum, but because of the negative in front instead of the minimum, it goes to its maximum, and then it goes to 0. And normally we would sketch in the sine function, but we can't in this case because this is not the graph that we need. We need a +1. See the +1? So what that does is that just takes each one of these points and shifts them up 1 unit. So the point would be here, 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 and here. And then what you can do is you can come back and erase the dots. I'm not going to erase this because if I erase it, it'll erase the whole line. So, but you can go back through and erase them. I've just got them in different colors here. Okay, and if you don't need to put these dots, if you can just say, okay, it starts out at 0, but it goes up 1 and draw your dot there, that's fine. All right, so now let's go ahead and draw in our sine function. All right, so there's our sine function, the 1 minus 2 sine. Okay, now we need our vertical asymptotes. Okay, now remember that cosecant x is equal to 1 over sine x. So when sine is 0, cosecant is undefined because it would be 1 over 0. Well, where is the sine function 0? Well, it doesn't look like 0 anywhere, does it? But it is. Okay? Remember, these points are this function here plus 1. So what we're looking at here, if you just kind of take that out, we want to know, when is this 0? Well, we did that. It's 0 here, here, and here. So that's where our vertical asymptotes are going to be. So we draw in our vertical asymptotes. And remember, when you draw in your sine function, you draw it in with a dashed line because it's not part of the graph. We're just using it as a guide. Okay? And so now we're ready to draw in our cosecant function. Well, you see here, we draw our U-shaped branches here for our graph of cosecant. And there's the graph of cosecant. And you can see as sine gets smaller and smaller here, cosecant's getting larger and larger. Okay? Because look, you see this is the sine function. As the y values on the sine function, as they get smaller and smaller, that means the denominator here is getting smaller and smaller. So, and as the denominator gets smaller and smaller, the whole fraction gets larger and larger, and that's why it's going up to infinity. And then the same argument down here, except, of course, as it's going this way, well, what's happening? You've got negative values. So that's what makes it negative. It makes it go to negative infinity. All right. So check out the other videos. Give me a like, share, and subscribe. And thanks for watching.